Hello, geometry students. Today we're going to talk about what happens when the lines that are intersected by a transversal are parallel. So today we're going to talk about properties of parallel lines. First of all, what are parallel lines? As a review, parallel lines are coplanar lines that never intersect. In this case, you can see. Now, one of the symbols for parallel lines is this symbol right here, these two straight lines that look like parallel lines. Now, skew lines, on the other hand, are non-coplanar lines that never intersect. And I know we've defined that before, but just as a review, and parallel planes are planes that never intersect. So now for parallel lines, there are two possible symbols that you could see that would indicate to you that the lines are parallel. One possible symbol are these fat arrowheads that match. And the other symbol is, like on the previous slide, line A is parallel to line B. If you are given the fact that they're parallel, I'm going to tell you properties in this video. Everything I tell you today is only true if the lines are parallel. If they're not, you could still have special angle pairs formed, but they won't have any special relationships. Okay, so here's our first one for the day. If a transversal intersects two parallel lines, same side interior angles are supplementary. And if that's true, we remember that supplementary angles are two angles that add up to 180. And so if you are given parallel lines, these are same side interior angles, so their measurements would add to 180. If these are parallel lines given by that symbol and this symbol, then these are same side interior angles and they would also be supplementary. So if you have parallel lines, then same side interior angles are supplementary. So pause the video and find X using that property. The first thing you would do is you'd ask yourself, are the lines parallel? And because we see the arrowheads, we say, yes, they are parallel lines. Only then can we use these properties. And then we'd ask, well, what kind of angles are we given? We see the U, so we know those are same side of the transversal, and interior, same side interior angles. So now we know we have parallel lines and same side interior angles. So now we can ask ourselves, what theorem or postulate can we use? We can use the postulate that says if a transversal intersects two parallel lines, same side interior angles will be supplementary, and therefore these two angles add up to 180. And then we can use our algebra skills to solve for X. The next theorem we're going to learn today is if a transversal intersects two parallel lines, alternate interior angles will be congruent. So alternate interior angles was the Z, so 5 and 6, or backwards Z, 7 and 8. And we remember that congruent angles are angles whose measurements are equal. And so if we see their parallel lines, or if we're given we have parallel lines, like here with these arrowheads, then we know that alternate interior angles are congruent, therefore their measurements will be equal. So pause the video and solve for X and Y. We're going to have to do it in two phases. First, we'll find X. Well, our steps are, first we'll ask, are the lines parallel? And because of those arrowheads, we can conclude that A is parallel to B. That's what's given to us. That's what that symbol means. Then we ask, what kind of angles include X? Well, we can make a Z here, and so we see that X and this angle that measures 70 are alternate interior angles. So if we have parallel lines and alternate interior angles, what theorem can we use? We can use the theorem that states if a transversal intersects two parallel lines, alternate interior angles will be congruent. And congruency means their measurements are equal, and so X will be 70 degrees. Next, we'll focus on Y. We'll do the same steps. First question, are the lines parallel? Yes, because we have those arrowheads, A is parallel to B. Then we'll ask what kind of angles are formed that include Y. Here's my U that includes Y, that includes the parallel lines in Y. and those are, this is the transversal in this case, and those are same side interior angles, two lines and the transversal. And so next step is, which postulate do we use? We have parallel lines and same side interior angles, so we'll use the first one we talked about today. If a transversal intersects two parallel lines, same side interior angles are supplementary. And supplementary means they add up to 180. So y plus 90, because the little box things means 90, equals 180, and we solve for y. Next theorem. Next property of parallel lines. If a transversal intersects two parallel lines, corresponding angles are congruent. And we know congruency means their measurements must be the same. Now just remember that there are always four pairs of corresponding angles. So when you're given parallel lines, that would be four pairs of congruent angles, if and only if you have the blue lines are parallel. So pause the video and find all the missing angles in this diagram. You're given that J is parallel to K. That's what these fat matching arrowheads mean. And you're given that measurement of angle 3 is 102. Vertical angles are congruent. Parallel lines cut by transversal alternate interior angles are congruent. Linear pairs are supplementary. Vertical angles are congruent. Linear pairs are supplementary. And J is parallel to K. Corresponding angles are congruent. Next theorem, if a transversal intersects two parallel lines, alternate exterior angles are also congruent. Exterior, alternate sides of the transversal. Remember, there are going to be two different pairs of alternate exterior angles, and remember, congruency means their measurements will be equal. And again, this is only true if the lines are parallel. So pause the video and solve for y. Our first step is to ask, are the lines parallel? And yes, they are, because we have these matching arrowheads that tell us they're parallel. Next, we ask, what kind of angles are these? And we see that they're alternate exterior angles on alternate sides of the transversal and on exterior space of the two lines. And then we ask, what theorem could we use? And we use the theorem that states, if transversal intersects two parallel lines, alternate exterior angles are congruent, which means their measurements are equal. So we can set those expressions for their measurements equal to each other and solve for y. Pause the video and find all the missing angles in the diagram. These are parallel lines. Corresponding angles are congruent. Vertical angles are congruent. Corresponding angles are congruent. Linear pairs are supplementary. Pause the video and solve for x. So our first step is to ask, are the lines parallel? And yes, they are. That's what the matching fat arrowheads mean. Next, we ask, what kind of angles are these? And we see an upside down backwards F, and we see that they're corresponding. They're both on top of their line and to the right of the transversal. Then we ask, what theorem or postulate do we use? And we use the one that states, if a transversal intersects two parallel lines, corresponding angles are congruent. And congruency means their measurements are equal, so we set them equal and solve for x. And that is it for our properties of parallel lines. And I will leave you with these cute kittens and wish you a great day.